All right, so you're going to want to have out your 6-3 notes, and we are going to be looking at polynomials. We've been looking at monomials, and today we're going to start looking at polynomials. Um, and with these, we want to be able to add and subtract polynomials. So you have these written down on your 6-3 note sheet. So looking at the little boxes on there, a polynomial is made up of monomials. Remember, a monomial is a single term, like 3x and 5 there. So you've got three different monomials here. You got 2x squared, and you've got 3x, and you've got 5. And they're put together either by addition or subtraction. So it has multiple terms there. And then we've got a binomial. That's a polynomial that has two terms. For instance, 3a to the third plus 4 times b to the negative 2. That would be a binomial because there's two terms. The 3a to the third is one term, and the 4b to the negative 2 is another term, and they're connected with addition there. And then the third little box there says a trinomial is a polynomial made up of three terms. So 5n to the fourth is one term, another one is negative 2n squared, and the third one there is 10, and it's connected there by addition. So like I said, today we're going to add and subtract polynomials. The first one here, we're going to look at the horizontal method here. So what you want to do with addition is just go ahead and add the like terms from each of the parentheses here. So there's no distributing of anything, just combine like terms. So you really don't need these parentheses here with addition. You can simply just rewrite it without it if the parentheses there are confusing you. And that way you don't have to distribute anything. You just simply go ahead and combine like terms. It's not equal to anything, so you can't add anything to both sides. You're simply combining your like terms. So for instance there, if I combine my x squared terms, you've got a negative 3x squared plus 5x squared there gives me 2x squared. So combining negative 3 plus 5 there gives me 2. Notice with the minus 3x squared, I took the negative sign in front of the 3 there. So whatever sign's in front of it, that's the one you're going to use. All right, so let's look at our x terms here next. We've got 2x plus 7x there. He's going to give us plus 9x. And then our other one here, our last one here, we're just going to combine our constants here. We've got 6 minus 10 there, gives us a minus 4. So there it is, 2x squared plus 9x minus 4. And notice I've got my x squared term, then my x term, and then my constant term there last. So highest power of x you put first, then it decreases as you go across. So 2x squared plus 9x minus 4. So there we use the horizontal method. We simply just combine our like terms there. We can also use what's called the vertical method. So notice over here you got an airplane here, or a jet here going straight up. It's because we're going to use the vertical method now. So vertical method, if you line them up vertically, minus 8 plus x squared. And then underneath it, I'm going to make sure the like terms are right underneath it. Minus 8 plus 6x squared. So vertically, I line them up. I'm going to add together my like terms. So 9x plus 10x is 19x. You've got a negative 8 plus a negative 8 gives me a minus 16. And I've got a 1x squared plus a 6x squared is a 7x squared. And then I'm just going to put them in the correct order here. The x squared term there goes first, then the x term, and then last my constant term. So there's my nice final answer, 7x squared plus 19x minus 16. And notice I was fortunate with this one here because the terms at the very beginning were already lined up. You had a 9x, then a 10x, minus 8, and a minus 8, an x squared, and a 6x squared. If they're not lined up nicely like that, if you use the vertical method, you're going to have to line them up correctly and put them in the correct order so that you can the like terms there end up lining up for you, and you could just add them together. So I've got a problem here for you to work out. You can decide if you're going to use the horizontal method or if you're going to go ahead and use the vertical method. So if you're going to use the horizontal method, you can get rid of the parentheses and just simply combine like terms. If you're going to use a vertical method, then you want to line them up and then put them right underneath each other. So I'm going to give you a minute or so here to go ahead and see if you can figure that one out. So take some time right now and try to figure that out. All right, so you just went ahead and figured this one out. Let me do it both ways here. I'm going to go ahead and use the horizontal method. So if I were to use the horizontal method, I'm just going to simply eliminate my parentheses here since it's addition in between. I could do that. And I can simply combine my like terms. So I'm going to go with the highest power of a there first. And there's only one of those terms. It's right here. So I'm simply going to write it down. There's nothing to combine it with. And then there's no a to the third, but there's a to the seconds. So I'm going to do this next. 3a squared plus 8a squared gives me 11a squared. And then I've got a's there. I've got a minus 5a and a minus 4a gives me a minus 9a. And then last, I can see my final terms there. I've got 6 plus 10 there on the outsides there. 6 plus 10 there is 16. So there it is, 10a to the fourth plus 11a squared minus 9a plus 16. So hopefully all of you got that correct. If on the other hand, you decide, you know, I really kind of like this vertical method thing. So if I were to do that one, I'm just going to go ahead and write the first one in parentheses there all by itself. And then I'm going to take the other one there and I'm going to put it right underneath it. But as I do it, I'm going to line up the terms. So 8a squared is going to go underneath the 3a squared. A minus 4a is going to go underneath the minus 5a. And then plus 10 is going to go over here underneath the 16, or underneath the 6. So now I can simply add these together. So I can add 10 plus 6 is 16. 3a squared plus 8a squared is 11a squared. Minus 5a and a minus 4a gives me minus 9a. And then I've got 10a to the fourth. Now again, that's not in the correct order, so I'm going to have to rearrange those. I'm going to put a to the fourth there first, so 10a to the fourth. And then I've got 11a squared and a minus 9a, and then plus 16. So just like the horizontal method with the vertical method, we got exactly the same answer. So it's up to you. Do you want to use the vertical method or the horizontal method? It's completely your choice. All right, so now we've covered adding polynomials. Now we're going to cover subtracting polynomials. And subtracting is just like adding. And you can use either the horizontal or vertical method. Just remember the negative needs to get distributed to everything inside the parentheses here. So if I go ahead and use the horizontal method, I have to distribute the negative sign through the parentheses here. So I get 9y squared plus 4y minus 8. So that one stays exactly the same. The first set of parentheses, there's no change. So distribute the minus sign, I get a minus 2y minus 10 and a plus y squared. So you're going to change the signs of everything in the second parentheses. So then I just combine my like terms. So I've got this 9y squared plus 1y squared gives me 10y squared. I've got this minus 4y, or plus 4y minus 2y gives me a plus 2y. And then I've got that negative 8 minus 10 gives me a minus 18. So there it is using the horizontal method. If you're a person, again, who likes that vertical method, let's use that as well. So I'm going to line it up. So 9y squared plus 4y minus 8. And I'm going to distribute the minus sign through as I write this down. So minus 2y is going to go underneath here. A minus 10 here is going to go underneath the minus 8. And then a minus here becomes a y squared. So now, because I've already distributed the minus through, I'm just going to add. So 9y squared plus 1y squared here is 10y squared. 4y minus 2y here is plus 2y. And negative 8 plus the negative 10 here gives me minus 18. So notice that we get exactly the same answer whether we use the horizontal or vertical method. So now I've got another one here for you to go ahead and try. We've got 5x minus 8 plus 3x squared plus 7x to the third in parentheses minus in parentheses 4x to the third plus 3x squared minus 2x. So again, if I were to do this one using the vertical method, I would just write it out, the first one exactly the way it is. I would distribute the minus sign through, so I get a minus 4x to the third, so I'm going to put that underneath. I've got a minus 3x squared, put that underneath the x squared, and I've got a minus 2x gives me a plus 2x. So lining those up, and since I already distributed the minus through, I could simply add those together. So 5x plus 2x here is 7x. You can bring down the minus 8. 3x squared minus 3x squared, they get canceled out. I've got 7x to the third minus 4x to the third gives me a plus 3x to the third. And then I just got to put them in the right order. The highest power of x is x to the third. Then we just got to plain x. And then we got our constant. So there I used it using the vertical method. So if I were to use the horizontal method, 5x minus 8 plus 3x squared plus 7x to the third, I can distribute that minus sign through the parentheses, and I get a minus 4x to the third minus 3x squared, and then a minus there becomes a plus 2x. Combining my like terms, so I'm going to combine those. I get 3x to the third. I've got a plus 3x and a minus 3x squared. So a positive 3x squared minus the 3x squared gives me 0x squared, so they're gone. And then I've got a 5x there, plus 2x gives me a plus 7x. And then a negative 8, nothing to combine that with, so minus 8. So again, you choose horizontal method or vertical method, whichever one works for you. So that's the first part that we are going to work through, and then we got some applications of this. So you can go ahead and work on your worksheet for the all the way up to the application problems where you see the geometry.